To use Phyphox, you can access it from your home screen of an iPhone or other smartphone. I got this from the iOS Apple Store. However, you can also get this from the Google Play Store on Android. Phyphox has access to many different kinds of tools. They range from raw sensors, acoustics, everyday live meters, mechanics, timers, and other tools. Today, in our video, we will be covering acceleration without G, audio spectrum, and elevator.
Today, one of the features I'll be going over is the audio spectrum. Displays the frequency spectrum of an audio signal. Click on this, there's a bunch of settings. Here's the spectrum. It shows a waveform, it shows the peak frequencies, it shows the frequencies that it can pick up. 257 is around pretty much exactly where a Yamaha keyboard, the C4, that's what the frequency is. You can go to history and see some peak frequencies, the frequencies that it picked up during the recording time. You can go to settings, set the sample rate. What the sample rate does is that more samples makes it slower, but you get a better resolution for this graph. And raw data, you can see the raw inputs here. These frequencies, I don't know, I can't zoom in, but those frequencies are when I'm playing notes. And if I click on the three dots in this right corner, I can access the experiment info. Display the frequency spectrum of an audio signal. This experiment records audio from the microphone and calculates its frequency spectrum through a Fourier transformation. You can also access the wiki from that page. You can export data, take a screenshot of it, time a run, and also save the experiment state. If I save it to collection, I should now be able to access it right here. I can go back and check back on what I recorded. So according to online sources, the C4 on a Yamaha keyboard should be at 261.6 Hertz, and we measured it to be 257.81 Hertz. And using a percent error calculation, we see that the percent error is only 1.4%, which is pretty good. So it seems that the acoustics on this app are pretty accurate.
Okay.
So right now, what I'm going to be testing is the acceleration without gravity, or the gravitational acceleration taken into consideration. I click here to put it on absolute mode. That way I get a graph of a function of time versus acceleration, which makes it really easy to tell what the acceleration is. On these other modes, if you play it, you can see it might be harder to tell what the acceleration is, but on this absolute one, if I shake the phone, you can see the acceleration goes way up and it makes it easier to tell. So I'll delete that and I will test it again. I'll put it lying flat here. According to their website, this should be the Z acceleration. So I'm running it from 60 centimeters. So there's 60 centimeters of string here before stops. And I'll be running it now. Start it and let go. So it looks like the highest recorded absolute acceleration was over 20 meters per second squared. And the simple acceleration, let me see if I can find it. I can hit pick data and look at this spot up here. This should be the, oh, this looks like it's the y-axis and not actually the z-axis. So I guess I was incorrect. The z-axis, or y-axis, pick up here, 1.5 seconds in, 24 meters per second acceleration. And yeah. So I have my, don't mind this, I have my free body diagrams up here. M2 is being pulled by M1, and or these are the free body diagrams rather. The force is acting on M2, just the tension coming from this string. the normal force and force of gravity cancel out, and the forces acting on the spice bottle pulling it, tension and gravity. So sum of forces, Newton's second law, T equals M2A, and over here, M1G minus T, because it's going downwards and downwards is the positive direction, so it's M1G, equals M1A. And then we just replace T, we substitute T rather, with M2A, so M1G minus M2A equals M1A. And we shuffle stuff around, M1G equals M1A plus M2A. This moves to the other side. Then shuffle more stuff around, factor out M1 plus M2A. Then you divide it from the other side and you end with this equation. These are our values, M1, M2, and the two masses together. Then distance, that doesn't really matter. Yeah. 0.125 times 9.81 gravitational constant acceleration divided by the two masses together equals 1.17 meters per second squared, which is very different from what the app said.
So this is the elevator feature. It is used to measure the acceleration of an elevator and the objects within it along its path up and down. At this part in the video, the elevator I was in was at a standstill, which is why the accelerometer is reading like an average of 0. As we continue the video, we'll see that there is an increase in the acceleration. This is when the elevator began to move and was speeding up from its standstill. However, soon after, the acceleration drops back to 0, and this isn't because the elevator itself stopped moving, but rather it reached its constant velocity, which it traveled at during the majority of its path. And as we continue, we'll see that there is a sharp decrease or deceleration, which is signifying the elevator slowing down as it approaches its final destination and stops. And then once again, the acceleration levels out back to 0, signifying that the elevator has stopped moving completely. So when it comes to the pros and cons of Phyphox, there are a wide range of features to use. This makes the app very versatile in its applications, and we had a lot of fun trying out the different uses of the app until eventually settling down on the 3 that we covered in this video. A con to this, though, is some of the features are hard to understand and kind of unclear how to use. There is wiki support on the app and the tools. However, it only covers the experiments that can be conducted with the tools, but not actually a breakdown of how to use the tools themselves. Some of the features also don't seem to work as intended. We found this especially in inelastic and elastic collision, which took it out of, which we ruled it out as something we could cover in this video. And it's also difficult to get consistent and accurate results over many tests. We found this mainly in the acceleration without G tool, which we did cover in this video. However, what's nice about the app is it is convenient and easily accessible. By that, I mean that you can simply get this on your phone and use it without any need for outside tools or outside external devices, meaning that it's accessible to anyone who has a phone. To make it even better, there's no paywall, so you don't have to worry about any subscriptions or price tags hanging over your head as you're downloading the app. Despite the fact that Phyphox has some tools which may not work as intended or are hard to understand how to use, the wide variety of tools given to the users and the fact that it has no paywall behind it and is easily accessible to many people if they have a phone, we can confidently give Phyphox a solid 3.5 out of 5 stars.